So we are on live. Sir.
Yes. Good. Okay.
So all are entering, sir. Around 47. Sir.
So, Subramani,
Yes,
can you start now?
thank you.
Yes, proceed.
You kindly all can turn your videos on.
Yes.
Good afternoon, all. On behalf of the management of E.G.S. Pillay Engineering College, I welcome you all for this event. Please make sure you use all the options available. Polls will be posted periodically. Check in the options. Post your questions on the chat box periodically. Now I call upon Dr. T. Suresh Badrinavan sir to deliver the welcome address.
So good afternoon, everybody. It's my immense pleasure to welcome you all for this industry webinar. First of all, I would like to thank our management, that is our Honorable Chairman, beloved Secretary, our beloved Principal, our CEO, and our Head of the Department for conducting this type of industry seminar. So I would like to welcome our Chief Guest, Mr. Vishweshwaran J, who is a resource person today, who is a head for South Indian program, National Instruments Bangalore, who is going to give presentation on the recent topic related to academia that is going to change something in the laboratory setup. So I welcome you, sir, on behalf of our department and our HOD and my colleagues, and on my own behalf, I welcome you, sir.
Thank you.
And I also welcome our beloved HOD, Dr. V. Mohan, who is the backbone of this event. I welcome you, sir. And I would like to welcome all the participants from various institutions of this country and also from abroad. I welcome you all for this wonderful session. And I also welcome the students, UG as well as PG students, also the PhD research scholars from various parts of the country. I welcome you all. Once again, I welcome you all. Thank you.
Thank you, sir. Now I call upon our beloved head of the department, Dr. V. Mohan sir, to deliver the introduction about our chief guest.
Thank you, Subramani. Good afternoon to all. On behalf of our management, the faculty members of EEE department, and the participants, I once again welcome our resource person, Mr. J. Vishweshwaran. Welcome, Vishweshwaran. We are very proud to have you as a speaker for this today's industry webinar session. Mr. Vishweshwaran has graduated in Electronics and Communication Engineering from Bharatiyar College of Engineering and Technology, Karaikal, Pondicherry University in the year 2003. He has a good number of experience in both the teaching as well as in industry. He has been in association with National Instruments Bangalore for more than 1 decade, and presently he is the territory manager for the academic programs being organized by the National Instruments Bangalore. So with this brief introduction, I welcome Mr. Vishweshwaran. Thanks, Subramani, for this opportunity given to me. Thank you.
Thank you, sir. Without wasting any time, we will hand over the session to Mr. J. Vishweshwaran, sir.
Thank you. Very good afternoon to all of you. Hope my audio and video is clear.
Yes.
Okay, great. I will share my presentation. So, can you able to see the screen?
Yes, sir.
Okay, I will disconnect the video for a good network to cover, and then I will switch it on again in the last. Okay, so in my watch, the time is at 2:37. So first of all, thank you so much for the invitation given by E.G.S. Pillay College of Engineering, and I'm very proud and very happy to be part of this industry webinar. and very happy to interact with the academic community for next 45 to 50 minutes to share some of my thoughts, which I acquired last 10, 12 years, spending time in industry, and being a very tough situation for all of us. How do we prepare the current engineering students ready for industry tomorrow? So that's why if you look at the topic, I'm not going to talk too much technical. At the same time, I'm not going to talk too much the Gyan kind of session here. I'm going to share most of the things, what are all the best practices followed in India as well as outside India, in order to prepare students ready for industry in this new normal way. We know the normal way, so we will be listen what is the new normal way. Okay, I don't know, many of you know National Instruments. The company started in the year 1976. We have successfully completed 44 years, being the leader in test and measurements and automation. Very recently, we evolved as new verbal identity as well as new visual identity as NI. So probably you can spend time in NI website and you will get to know what new evolution we introduced as a company 100-year plan. I'm going to take out your time, the next 4 slides, to share what is happening in and around. As a first slide, in the recent past, probably 3 months or last 3 years, if you interact with your peers, friends, industry folks, some seminars, conferences, workshops, whatever you interacted, attended, participated, etc., you might have been heard some of the very, very interesting buzzwords like this, starting from AI, AR, VR, right? So these are some of the commonly used technology buzzwords last 3-4 years of time, right? Including the financial technology, fintech. Even some of the universities started teaching, introducing gaming technology where they see a lot of potential markets. You all are aware, IoT, Internet of Everything, IoE, 5G, Industry 4.0, interdisciplinary cyber-physical system, etc., etc. So these are the technology. The big question mark to all of us is, how do we prepare our students in these technologies? Should I teach AI, or should I teach 5G, or should I teach robotics? And if I continue to decide and teach any of these technologies as a curriculum, there is a big question mark whether it will be the same after 3 years, 5 years down the line, because there are no such technology 5 years before, right? Very, very few people are aware what is cyber physical system or 5G. So the one thing is, these are the industry trends, industry technology buzzwords happening in front of us. The another thing is, if we continue to teach this technology, what will happen after 3 years, 5 years down the line? Just to pass this question with you, let us find the answer together. The next slide which I wanted to share is, you all are academic community, so I don't need to tell what is the normal form in education system. You have a classroom environment where you will accommodate 60, 70, 80 students. You have a defined classroom college timings. Some colleges starts at 8 o'clock, go up to 3, and 9 to 4, etc. And always students believe teachers as only go-to person when it comes to the doubt, when it comes to the knowledge, when it comes to the support system, etc., etc. So teacher as a guru, teacher as a only go-to person in the normal education. We have a traditional conventional labs where the lab will be conducted for a period of 2.5 hours, and we have a set of defined experiments where our students will be asked to do those experiments. And typically we also assess our students by conducting internal assessment exam or monthly test, or we will also have a final exam for a time period of 2.5 3 hours. That is a normal in education system, lasts so many years. Yeah, this is another very interesting. There are some colleges will not encourage the students to bring mobile phones. The new normal is exactly opposite. You cannot limit your learning, your teaching in a classroom environment. The evolution happening is learn anywhere, anytime, at the pace you want. You may be a fast learner, you may be a slow learner. You decide how fast you wanted to learn. There is no blackboard, white chalk piece method of teaching learning. It will be more of online. You all are experienced last few months, and there are popular learning methodology you have seen, including Baiju. My daughter, who is class 4, class 5, they are encouraged to use online mode of learning. You also heard from MHRD, state government universities also, to leverage the virtual laboratories, where at least the students will be able to visualize all the experiments, not in the real form. And people also talk about recently remote labs. I will also give some details about what would be the difference between the virtual labs and the remote labs. And we also have something called do it yourself or build your own device. So the new normal is not limited with specific time or specific place when it comes to the teaching learning. It is going to be more of a digital mode of learning, remotely accessing the lab to the extent where you can build your own lab, your own experiment. Okay, now let us pass this information. This is a new normal, right, in the education. Take a look what industry is looking for as the competency, as the skill from the students when they graduate from the engineering. So there is a survey which says about these are the skills what exactly industry is looking from the engineering graduates, which talks about critical thinking, which talk about teamwork skills, which will talk about ability to deal complex problems, which will talk about applying the foundation knowledge, engineering knowledge, whatever they acquired in the first year, second year, third year, out of box thinking, system level thinking, flexibility to adapt, right? You cannot be rigid and say, hey, no, I will continue to teach only this method. No, you have to be flexible enough to adapt, etc., listed here. So nowhere the industries are saying, hey, I need a student or fresh engineer with Python programming here, at least in this slide. They're talking about the foundations of engineering should be important. They should know how to apply that engineering knowledge, out of box thinking, leadership skill, creativity, etc. So this is the majority of the industry, at least 85% of the core engineering industry is looking from the fresh engineering graduates today. Keep aside this particular slide also. Look at the NAE, which is the National Academy of Engineering, which talks about Global Grand Engineering Challenge. So they listed these are the top 10, 12 grand engineering challenges which is going to be faced by every individual in the world, starting from reverse engineer, nuclear terror, better medicines. This is the exact time we all are facing the challenge when it comes to the healthcare, getting the clean water, virtual reality, personalized learning, cyber security, because everything is online, everything is digital, including our payment mode. So how much we are secured when it comes to the digital environment. And very interestingly to note, tools for scientific discovery. Do we have a right tools with us where the innovation can happen fast, the discovery can happen fast? So if you look at all these 4 slides in a collective consolidated way, if we decided to prepare our students to solve this 100-year problem, or we call it as a sustainable development goal for the country, if that is our intention to prepare the students, then you cannot prepare the students without adapting the new normal way of education system, which is online, which is digital, which is anywhere, anytime, which is remote lab, which is do it yourself, etc., etc. And that will not complete unless otherwise you implement some of the industry required skills to prove that they can solve these global grand challenges. For example, out of box thinking, creative thinking, team working, applying the engineering knowledge, whatever they acquired in the new normal education system, using the current industry standard technology like IoT or machine learning or deep learning or 5G, etc., etc. So there is a very strong connect in these 4 slides, and it is the biggest responsibility of you as well as me as an industry to prepare our students ready for the 21st century. Okay, this is also very interesting to note. You might be aware and you might be guiding some of your students for doing their PhD research. Always researchers try to discover what nobody knows, right? That is what they do 3 years, 5 years time. Students, the undergraduate or postgraduate level students, most likely they will try to find what they don't know. The very important component in both of the category is how fast they can find that, how fast the discovery can happen, because we don't have infinite time today. We have a very, very limited time. If it is a undergraduate program or postgraduate program, even the PhD program, we don't have infinite time. It is not only in your education system, even in industry. We have to release a product before our competitor releases a product in the market. You know the Nokia stories. You know what happened when Nokia have a reservation to adopt some of the cutting edge technology in the mobile industries. The same way, it is very important in the given limited amount of time what we have, how do we prepare the students so that the innovation can happen, so that they can solve the world's grand engineering problems. I have some of the thoughts which I acquired based on the interaction with the industry as well as academicians like you. So I'm going to share those things here. The first thing is convergence. There are many universities in India, you may be noticed in the recent past, they don't want to, they want to start a program of engineering. They don't want to start a program only of electrical and electronics engineering or mechanical engineering alone, which is a conventional way of engineering, right? So they wanted to give an opportunity where students of an electrical and electronics engineer can pick few subjects of mechanical, few subjects of computer science, few subjects of civil, few subjects of MBA, management, business administration, arts and science, and they can do a major and minor program. And even there are very good interaction happening in India with the leadership of Department of Education. How do we introduce the interdisciplinary teaching learning for engineering students? Few years before, AICTE recommended a model curriculum. Some of the universities already started implementing the model curriculum where the internship is mandatory for every year student. And today there is a very good example of automotive industry. You take 90% of your vehicle today is not mechanical. It has electronics, it has embedded system, it has communication units, it has a lot of information, a lot of data, a lot of entertainment. So how do you prepare a mechanical engineer only to work in automotive industries? So biggest challenge. Unless otherwise you converge the engineering and focus on solving the problem rather than preparing a students with bookish knowledge, you cannot really build engineers to solve the global grand challenge. So convergence is the one very critical component we should prepare our current generation students. The second thing, it's a very interesting statement. I have not failed. I learned 10,000 ways that does not work. So what it means is, we should give an opportunity for our students to fail fast. Fail fast. If somebody is getting the output in the first attempt in the laboratory, please note that there is a serious problem in the circuit or serious problem with the student. Because I did my engineering 15 years before. I never get my output in the first attempt. I have to keep on doing back and forth, identify, troubleshoot, etc., etc. And the failure gives always the learning. So we should be very clear in teaching learning to our students and making sure the students will learn by failure. I will also take some of the examples. Most of the people in the education system, most of the people always think that to solve a problem, I have to follow a standard process and ending up getting a success or failure. It's a natural, high likely people try to do. But if you look at the smart people in the classroom or smart people in any place, they will not just listen and repeat what you are doing, what you are saying. They'll always try to do some alternates, try to do different things. Obviously, when they are trying to do different things, they will fail. Sometimes they will succeed, sometimes they will fail. But each failure will give them learning. And that learning will give them confidence and knowledge and prepare them to become an entrepreneur today. They will say, hey, I don't want to sit for the campus recruitment from so-and-so company because I know engineering, I know control system, I know electrical machines, I know industrial automation. So I will try for some good job at good company. If I'm not getting, probably I will start my own. That is possible because he or she is confident, hands-on experience, failed many times, and they are not fear of the technology, they are not fear of the failures, and they are able to be a job provider rather than job seekers in the market. So the second input for all of you is allow your students to fail fast. And this is a very interesting slide which I used to show it in many places. If you continue to be in the conventional mode of teaching and your students are just hearing, please remember the same minute there is a very high likely they will forget, because you're teaching, they are listening, hearing. But in your teaching, if you stop presenting and show some animations, show some visualizations, show the AM modulated signal, show how a transformer works, show how IC engine, 4-stroke engine works, and teach them what is happening in first stroke, second stroke, third stroke, fourth stroke, then what will happen? Because they are seeing, they will remember the concepts. It cannot easily forget. After 1 year also, if you ask them, they will be able to explain whatever they seen because they remember. But ultimate is do. You should allow them to spend more time in the laboratory so that they will do experiment, do projects, fail fast, and that failure, that doing will help them to understand. I really appreciate there are a lot of universities in India adapted integrated courses, theory plus lab together, a 4-credit course, where 50% of the content will be taught as the theory, the remaining taught as the laboratory. And some colleges I have seen, there is no lab, there is no classroom. They created a space where the lab and the theory can go together. The faculty will teach a concept for 10 minutes, 15 minutes, and then remaining 40 minutes, the students will do the experiment. And by doing, they will learn, explore, right? I really wanted you all to try it out. Can we allow our students as much as possible to do so that they will understand and focus on solving the problem rather than learning only the theory components? Okay, how is it possible doing engineering. When we say doing engineering, the three important elements we should know is the core, concepts, subsystem, and the main system. The engineering system or main system, which is the right extreme, which is more of the current technology, 5G. When we are talking about 5G, when India is ready for adapting 5G, there is another group in Japan or Singapore or China, they started working on 6G. When we are talking about smart grid, another group of researchers working on microgrid. Similarly, when we are talking about cyber physical system, another group already started working on industry 5.0. So this piece, very, very less probability you and me can control. We have to adapt, we have to evolve, we have to prepare our students. But you cannot prepare your students for 5G or IIoT or massive MIMO system development unless otherwise they are confident, hands-on experience in the core concepts of engineering. You cannot skip your students not learning fundamentals of circuits, electronics, signal systems, DSP, sensors and actuators, etc. These are the core engineering concepts. So with the foundation knowledge of core engineering concepts, they can start building a small projects in the laboratory, in the semester end as a capstone, and then they can bring this knowledge to build a complex system of today or tomorrow. Because you cannot really prepare the students what is required for 6G in today's classroom. You have to prepare the students on this and this. And with these two strong knowledge, hands-on experience, they would be in the position to build any complex system of future. And that is what National Instrument is trying to do last 44 years, working very closely with academic and industry. We equip engineers and the enterprises with our systems to accelerate your productivity, innovation, and discovery. So we provide a very, very powerful software and hardware systems to you, and you decide, hey, I'm doing application related to biomedical, healthcare, assistive technology, and you will build a project or a product or a prototype so that the innovation can happen faster, the discovery can happen faster, your productivity will be improved. The same way, another group of communication experts, they will use National Instruments systems, the productive software and the modular hardware in a seamless integrated way, and they will be able to solve some of the 5G related research in the communication space. The same way, it is purely depends on the engineers and enterprises who is working on the specific domain or an application or an industry, and the systems which NI provides will help them to accelerate their innovation and discovery. Okay, this is another very interesting method. I recommend to try it out. We did this in few institutions in Tamil Nadu and Andhra Pradesh as a system engineering course. Our industry folks, my colleagues, go to a institute where we have a partnership. They develop a 3 single credit course, and they teach in 5th semester 1 credit, 6th semester another credit, 7th semester another credit, and the 8th semester they will be able to build a complete system. I'm not challenging you or doubting your teaching methodology, but there is a value which NI can add or industry can add, how to build a system from a simple fundamental blocks structured together and focus on building that product as a final stage. There are some universities, they started teaching the top-down approach method. For example, they will teach system design in the first semester, second semester. They'll teach how to build a robot, as a 2 credit course or 3 credit course in the first year or first semester. You may be asking, sir, when the student don't know what is signal processing, what is sensors, actuators, control system, how do they build the robot? How do they build a humanoid robot? How do they build a autonomous system? Today, my daughter, who is 3.5 years old, she is using Apple 7 phone, Apple 8 phone. She don't know anything. She don't know how to read it, but still she can able to use it. That is possible because of the excitement what they have. The tools which they are using is easy. In the same way, if we as educators provide the right tools to our students, which can stretch from the foundation level till the application level without changing different tools, then students also will get excited, will get inspired, will get motivated to build products in the final semester. They will not just stop at mathematical modeling and simulation level, because the tools are easy to use. And that is what National Instruments provides to the academic community and say, hey, we have a software and we have a hardware, and you decide what kind of complex to simple to medium level application you wanted to build. Now, I will stop here and show a poll. I would be happy to get input from you if you can answer this question. I saw somewhere around 200 plus participants for this program. The question back to all of us is, what challenge do you see in your online education? Because last 3 months you are trying to adapt some methods to complete your syllabus, complete your lab, complete your examination. So I wanted to understand from you, if you can go to www.menti.com, then it will ask you a passcode, type 139482, which is displayed in the screen. Sir, hope my screen is visible, right?
Yes.
Okay, great. So the participants request you to visit www.menti.com and type the code 139482. Then you will be given an opportunity to answer what is the challenge you faced when it comes to the online mode of education. Okay, I have given 4 options. One is student engagement. When the students are present physically in the classroom, we know what kind of challenge we face. It is very difficult to keep the attention focused for 50 minutes, right? So when you are in online, there is a very popular WhatsApp video I'm seeing last few days. One teacher is struggling a lot, literally crying when she is trying to do it in online. So engaging the students is one option. The second option is students are confused many times. You are trying to do something, and when you ask them to do something, they are coming back looks like confused. The third option, students feel isolated because they all are learned, practiced, grown last so many years from their LKG, pre-KG, UKG till class 12, till second year, third year, final year of engineering as a group, 60, 70 students. Now today they are sitting in their bedroom, and bedroom became a office or laboratory or a classroom for them. So they may feel I'm isolated. The fourth option is, as an educator, we are struggling. We don't know whether the students are really following what we are teaching or learning, because we are telling them as a first instruction, please mute yourself. Please don't switch on the video. So that is the first instruction we are trying to do when we are doing an online class, right? So we really don't know whether the students are able to follow or whether the students are learning or not. So I really wanted to get your insights, inputs. Probably the poll will be open for another 20 seconds or 30 seconds. Quickly go to www.menti.com and type the code 139482 and share your inputs so that we can go further on the slides. Is it only 15 people attending the program? My God. No. Let me see how many people are. 226. Okay. Only 10% voted. See, if this is the way I'm struggling to engage you. It is very well witnessed at this point of time how much struggle you have when you ask some question to 200 of your students and when they are responding like this. Don't say internet problem, don't say network, don't say your data rate is poor. Okay. There is a equal spread between students are confused most of the time. And another one is don't know students are really following or not. Okay. So I will keep this poll open for a few more seconds, but I will go back and share my slide. But please feel free to go and enter your inputs. This really will help us. What kind of problem as academic community today we all are facing? We are asking this question to understand. It is not just for understand. We also wanted to come back and say, hey, this is the solution. Why don't you try it out? Okay. So it's a good number. Around 55 people polled at this point of time. So 21 members said don't know whether the students are following or not, like the way I am reacting today now, right? So I don't know whether you are following or not. Great. So very good insights. Now let me go back to the slide and show you there are a lot of methods available when you try to do online education. I moved to the presentation slide, sir. Is it visible?
Yes, sir.
Okay.
Various methods of
Yes.
online education.
Yeah. So I know that there are a lot of institutions encourage the faculty to do online teaching, and you all are doing an awesome job when it comes to the theory. Very, very innovative way of teaching the theory. Somebody is using WhatsApp, somebody is using YouTube, somebody is using Zoom, etc., etc. When it comes to the teaching, I really appreciate all your efforts. What happened to the lab? Engineering is doing. Engineering is not theory. Unless otherwise you provide an opportunity for your students to fail fast in the learning of experiments or project, they cannot become a good engineer. They can become an engineering degree holder, but they cannot become a good engineer. So how do you handle the lab part? So I'm sharing a couple of my experience and some other things what globally practiced. One is simulation. So they will encourage the academic professors, faculty members, institution will recommend, hey, use some of the open source software tools available freely, and let us try doing something on the simulation level. Do some control system lab simulation, electrical circuit lab simulation, electronics lab simulation, some simulation level they will try to do. I appreciate that effort. Some colleges I have seen in the recent past, they have a very beautiful mode of step-by-step recording of an experiment. As if a student go to a lab and try to do an experiment, whatever the steps they will follow, everything the faculty member or a teaching assistant or a technician does, recorded very beautifully and shared it to the students. Only thing students will not be doing here, they will listen. As long as they have an internet, as long as they can interest to learn, they can visualize the step-by-step process, and they will get a feel, oh, this is the what I have to do a connection, this is the way I should switch it on, this is the way I should vary the input output, and this is the way I have to see the response. But they will not do anything, they will visualize everything as a recorded one. I really appreciate that innovation also happening by the academic community. The third way, remote lab. What is my remote lab? There are some universities that started thinking, I invested crores of money last so many years, set up this particular laboratory, which is a world-class, state-of-art lab with so many number of software, hardware that available in my lab. Today, because of the COVID, I'm not able to access those technology available in my lab. So can I use internet-enabled mode so that those lab infrastructure available in my college accessed by the students sitting in their home? Remote lab. Please remember, I'm not using a word very carefully, virtual lab here. Virtual lab almost similar to your first stage or second stage, video recording or simulation. I'm talking remote lab. You have a electrical machine setup, electrical benches, transformers, AC machine, DC machine, generators, everything available in your college. Today, you are not able to operate it, you are not able to access. So why don't I integrate with internet and sitting in your home, access that lab, remote lab. So I'm going to share a couple of things. Even if time permits, if things works, I will do a demonstration also to you. That will give some amount of learning experience, doing experience for your students. The ultimate is do it yourself. You fail yourself. Learning from experience by doing is ultimate. And that is called student-owned device, SOD. So there are 4 best practices I have seen last so many years used across the globe to empower the teaching learning process to develop a good quality engineers. It can be a simulation, it can be a video recording, remote lab, or SOD. I'm going to talk about all these 4 little bit. Probably I will not talk about the video recording. I will talk about simulation, remote lab, and the SOD as a support from National Instruments. We have a very interesting opportunity for students where they can install their licensed version of software in their machine, in their personal laptop or a desktop, which has all these features. I'm not talking about LabVIEW student edition. Please remember, I'm very carefully using LabVIEW professional version software. I'm listing all the toolkits for IoT application, communication, signal processing, MATLAB interface, vibration sound, machine learning, model interface, etc., as a package for student to own and perform more than 20 different type of experiments from first semester till the 7th semester, including projects, capstone, and final year main project. Because Multisim is one of the software available here in the package, and I can use it for almost 7-8 laboratories, which talks about all component level simulations. And using LabVIEW along with the signal processing toolkit, probably I will do a signals and systems lab, digital signal processing lab. Because today, you remember, your students are in home. And if you say, I have a software available in my college, I will put it in the server and I will allow the students to access. The students will come back with hundreds of reasons. My data rate is over, my internet is poor, so many things which you cannot imagine. So NI understood, hey, this is the biggest problem. How do we help the academic community to continue the teaching learning? So student-owned software. Remember, more details if you want, you can chat to me, you can write a mail to me, I will share the details also. This is the one way. The second one is remote engineering lab. That means your lab will be in the college premises, but students will do exactly what students does when they are in the campus, in the laboratory, in front of the circuit. So we developed and released a product called ELVIS 3, the 3rd generation hardware, which has very, very interesting features. First interesting feature is the breadboard. You can see here, there is a breadboard where you can build any type of circuit. The moment you build the circuit, you need source and measuring instruments. You can see the right side corner of this ELVIS hardware. There is a 4-channel oscilloscope. There is a 2-channel function generator up to 100 megasample per second. You have a voltage current analyzer, logical analyzer and pattern generator, power supply, multimeter, and bode analyzer where you wanted to calculate the phase margin and gain margin of a circuit. So that means the moment you build a circuit here and do the respective connections, right? And your circuit will be seen by the students remotely. What you need a camera basically, and you will use the NI software to access, wherein you will set, I wanted to generate a signal of 1 volt with the 1 kilohertz frequency, and I want to see my response in the oscilloscope channel 2. because the wiring connection is made, kept ready, and you will be able to remotely access, monitor, and control. This hardware also available with some of the very, very interesting feature for projects. It also have a to D, D2A converters. You can see here a good number of analog IO, digital IO lines. And it also have the Zinc 7020 FPGA as part of this device, ELVIS 3. So the one side of the hardware, you have all the source, test and measurement equipments. The other side of the device, you have to D, D2A converters with power supply, LED, switches, buttons. You can see here all these points, switches, LEDs, push buttons, audio input, output. And you also have in the back side of the device, FPGA. Interestingly, as I told you, this device can work in Wi-Fi, USB, as well as Ethernet. So the moment you connect this device to the IP, the network, students sitting in their home remotely log in and say, hey, this is the circuit built and kept it. I can video stream it, and I can get the access of the software, and I can change the parameter and see the responses. I will show you a demo also. Okay, let me go back and show the demo if the device is connected. Right now, you can see here, there is something called Measurements Live. This is the application software, will help me to access the device. You can see here, right now it says whether your device is connected in USB or network. Let me choose network. The device given with a specific device ID. So let me ask my colleague who is sitting in my office to share the device ID. Even probably if you have an internet, what you can do, you can go to measurementslive.ni.com. Measurementslive.ni.com is the website. You don't need to have any specific software for this. I just opened this URL and he has shared the ID, device ID as NI. Capital NI, one more I, OO, 2U, LC, capital X. Okay. I'm trying to connect the device. If the device is connected, set there, probably now I can see, yeah, you can see the disconnect option. That means the device is already connected. Now I can see all the instruments available in that hardware. I have oscilloscope, I have function generator, multimeter, etc., etc. The experiment which was set and ready for demonstration now is a high pass filter and a IV analyzer for a diode. So I can take the first experiment to demonstrate a Bode analyzer as an experiment. The moment I click the Bode analyzer, you can see a panel where I can calculate the phase margin and gain margin with respect to the frequency. I can set what is my start frequency and stop frequency, what type of steps I have to follow, etc., etc. here. The circuit is set already readily available for me to access. I don't have a camera there. I'm not able to show you parallelly in the same screen what is that circuit connection diagram. Probably if I have that feature also, then in one corner of my screen, you can see that also. Now let me run the program. Basically, it's a 1 kilo ohm and a 0.1 microfarad of capacitor they are used to build a high pass filter circuit. If you apply the mathematical equation to find the cutoff frequency, you can find it somewhere around 150 hertz. And it's a real data. Your students can visualize the circuit if the camera is connected and have a video streaming possible. Right now, I don't have that feature, but it is possible. And the students, without installing the software, they can log into the URL called Measurements Live. Now a group of students, suppose if the same device ID I shared to my another student, or you are a faculty member, I stuck here, I don't know whether my input, output, whatever I'm getting is right or not. I can share the device ID. You can also view along with me. I can see here multiple heads, and you can assist me as a peer learning, collaborative learning, and you can guide me where I did mistake, where I did correct, and you can take the print shot of the result, whatever you acquired. You can see there is a way to take your screenshot, and you can also transfer your data in an Excel sheet as a CSV form, export data, and sitting in your home, you are providing access of technology to the students where they can able to do exactly what they did it in laboratory, sitting in front of a circuit in the laboratory in the college. I'll show you one more example. I told I have an IV analyzer of a diode. So let me open a current voltage analyzer circuit. Run the program. So you know the diode characteristics. The 0.7 is a cutoff voltage. You have a cursor. You can track what is a voltage, what is a current, everything you can able to do it. So only one component in doing the experiment when they are physically present in the lab is, in addition to this, they will also try to do the wiring connection. Probably today we don't have that option. So we have to try whatever the rest we can do by skipping that wiring connection. But that wiring connection also, you can prepare the students by doing it in the simulation level. So again, if you look at, I'm not using any software here. I'm using something called Multisim Live. This is again a online resource where you no need to install any software, and you can able to build a circuit. You can see the list of components available, what type of component you want, right? Drag and drop those components and do the analysis. Whether you want to do a time domain analysis or you want to do a frequency domain analysis, you have the options, and run the program, and you will able to see the simulation result also. So what benefit you are giving it to the students in the new normal way of education system is, even though they are not physically present, still they can continue to do the simulation. Still they can continue to do the real experiment by connecting the internet as the mode of communication, and they can able to do a real-time measurement along with variation of their inputs, components, etc. Okay, so let me go back to a few more slides. I think I have very few slides. Another 2 minutes it will get over. If you remember, I have talked about 4 commonly used methods for online education to engage the students. One is the simulation level. The second one is the video recording. The third one is the remote lab. The fourth one I told, student owned device. SOD, student owned device. Look at the very interesting feature available in this device. It has power supply. That means the students don't need to have a separate power supply. It has commonly used instruments like multimeter, oscilloscope, function generator, arbitrary waveform generator, digital I/O, etc. It also have an analog input output, digital input output. This also have an integration with the software LabVIEW and Multisim. It also connected to the computer through USB. So that means if I have a breadboard, and if I have a respective components with me to build a circuit, I can use the breadboard and the components to build the circuit, and I will find which is the function generator terminal, which is the oscilloscope terminal. I watch the respective input output and visualize my result. There are universities in India adapted this technology, this method, to engage the students effectively in the new normal way. What are the experiments people can do, labs people can do using with this device? good number of projects, good number of courses they can do. You can visit ni.com website and you will get all the informations available. Good books also available there. I wanted to take few seconds to showcase there are more than 35,000 industries worldwide uses NI technology for design, automated testing, automated measurements, embedded monitoring, control, etc., etc. There are more than 7,500 universities uses NI platform for teaching as well as research globally. To name few, you can see the list in the screen. And there are a good number of organizations comes from research and development. They use NI platform. And let us prepare our students and be ready ourselves for work from home, learn from home, do it yourself, build your own, even work for, I don't know, multiple companies or many companies or multinational companies, right? So let us adapt to the new normal way of education system and prepare our students industry ready. Okay, I will go back to the poll and see what is the response. Wow, so 80 people responded. I really appreciate for your inputs. So 32 people said we don't know really whether the students are following or learning, right? So the remote lab will allow the faculty and students to work together so that you can able to see whether the students are able to learn, whether the students are able to understand and do it whatever you are saying. I have one more poll now. We are end of the presentation. So the next question is, when you understand there are different methods of engaging the students in the new normal way, the one recording the sessions, virtual lab, remote lab, student-owned software or student-owned device. What would be your recommendation to encourage students to do in the new normal way of education? So again, the same menti.com and enter the password 139482. And if you can share your thoughts, would be appreciated. So I am done, sir. So parallelly, the host, Dr. Mohan sir, or the team member from E.G.S. Pillay can unmute yourself. And I'm curious to see if there is a interesting questions in the chat box so that I can answer. So let it go.
Thank you, sir. Thank you for the wonderful session, sir.
Thank you, sir.
There are a lot of questions on the chat box. I hope Dr. T. Suresh Badunan sir has consolidated some of the questions. He will ask the questions to you.
Okay.
Actually, very few questions only. Most of them ask your PPT, sir.
Okay.
Can you share the PPT like that? And importantly, there are some humble questions for you. One is, how can we understand virtual labs? Like that, one fellow asked. Actually, you answered the thing in the presentation, I think. How can we understand the virtual labs? Can you provide the virtual lab links and all? Can you provide the virtual lab links? I have forwarded a few links related to the basic electronics and measurements. Related to the
It says somebody left the conversation. Joining.
It's some network issues. Kindly cop up for 10 seconds. It will be reconnected.
Completely, I understand, sir.
Yes, sir. That IIT Kharagpur, they are having virtual lab links that are shared with them.
Yeah.
Maybe they
if they can go to
questions from audience. Yes, sir.
If they can go to MHRD website, Google it as virtual lab, they will get all the relevant information, sir.
Mainly related to IIT Kharagpur. Wait, sir. Sir, next one is, whether any systems softwares are free for students. If then, how can we download and use it?
Okay. Nothing is free in the world. Take it from me. But because you are academic community, because you are a faculty member, because you are student, you will get a huge subsidized cost, right? So probably I will share my email ID and mobile number. If the individual can write it to me, I can understand better. When I say software, there are a lot of softwares available in NI. LabVIEW is the one software. LabVIEW with a lot of toolboxes, multi-sim, and so on. So what type of lab or what type of experiments or what purpose they are going to have it, accordingly I can help them what would be the subsidized cost for students. It will be cheaper than your Vivo phone, I can say, at this point of time.
Okay, great, sir. And can you actually in our faculty side we had a question. How can we use our electrical machines laboratory, that is core EEE department laboratory, fully hardware? How that can be integrated with our facility like remote lab? What are things to be done, or how to convert or transit from normal to new normal? Can you guide us?
Okay, sir. In a very high level at this point of time, I can say, in your electrical machines lab, you are trying to measure variety of signals like voltage, current, speed, torque, and so on. And you are doing it with conventional instruments, voltmeter, ammeter, tachometer, wattmeter, etc. Now, what I will do in new normal way is put the appropriate sensors there. Capture the sensor data through a A to D converter. The digitized data, bring it to your computer where you will do a lot of analytics. You will find what is the harmonic of the signal which I captured. What is the power by multiplying the voltage and current? What is the phase angle? What is the torque? So everything you will be able to either derive by acquiring few sensor data, or you will be able to put the right appropriate sensor to get the data directly in a digital form. Good example, I will take, this is the opportunity to tell you, there are colleges in Chennai, IIT Madras. If you get an opportunity to visit, go to the electrical machines lab in the ground floor, 40 benches, everything is PC based.
Oh.
And colleges like MEPCO in Shivakasi, they did it. SRM, they have done it. There are so many colleges who did it as one of the methods to engage the students in this tough time.
When the students are remotely monitoring and controlling the experiments, anybody, actually any lab assistant or any faculty has to be present in the laboratory to make safety of the equipments and other things?
Okay. The first answer is the moment you build the circuit, for example, let us take electronic circuit based lab, any type of circuit based lab. Any type of circuit based lab. The moment the respective circuit is built, kept it and connected to the computer which has the internet capability, ideally there is no physical presence of technician or faculty required in the lab. We will develop a software in such a way that the students will not vary the voltage value or the frequency value or a specific input value beyond a set point. Because your worry is, if the students give 30 volts, what will happen? I will not give the opportunity for him to vary more than 10 volts if the experiment does not require more than 10 volt signals, right? So that way we will be able to protect the circuit even though the physical presence of the faculty or technicians are not there, number one. Number two, there may be a possibility, I developed the common emitter amplifier with a specific standard resistor capacitor value. I wanted to change the bypass capacitor, coupling capacitor value. That time I have two options. If the faculty member or somebody available in the lab, they can physically change and put the different type of value of resistor or capacitor or op amp, or I can develop a circuit with the relays so that I can switch it in such a way that study the performance with a 1 microfarad capacitor, switch on the relay so that this will get disconnected. The another capacitor will get connected. I will study the performance of the circuit with the 0.1 microfarad also. In that case, the relay will do all the changes required for the circuit. We don't need to have a physical presence of the faculty or technician. And whatever I'm saying, I'm not talking in the air. These all are running in many colleges in India.
Yes. Thank you, sir. Thanks for answering.
Thank you, sir.
I would like to see any other participants are asking questions.
I will take this picture. There is a good response. Virtual lab versus remote lab versus SOD. Okay. When I asked the question, I asked you without thinking the investment part. You are an academician, you are a teacher, you are a professor. Your intention is to give a better experience to your students in the learning, in the experimentation. So I hope that the answers, whatever you have shared, is in that context. The moment you think, sir, already the student admissions are not happening, then I don't think so. You can give the right answer. Fine. Any other interesting questions, sir? Already I have taken 10 minutes more.
Thank you, sir. Thank you. Thank you all. It's my immense privilege to propose the vote of thanks on this occasion. On behalf of EEE department, I extend a very hearty vote of thanks to the chief guest, Mr. J. Visweswaran sir, for sharing the ideas of the life, which can definitely shape our careers in the upcoming days. Thank you, sir. Thank you for spending quality time apart from your busy schedule. Thank you, sir. I thank our management, CEO, sir, principal, sir, for their support. I express my gratitude to our HOD, Dr. V. Mohan, sir, for the encouragement and motivation. Without him, the webinar is not possible. Thank you, sir. I thank Dr. T. Sureswathanan, sir, and my co-staff members of my department, and also the student volunteers for their support. I thank all the participants for their active presentation. Feedbacks will be mailed to you, and also it is posted on the chat box. Kindly fill it and you will be getting the certificates automatically. Thank you. Thank you. Thank you all.